Welcome to the Meridian Economics Power Outlook Explorer. In this short tutorial, I'm going to show you how to use the dashboard and demonstrate three types of inquiry that you can perform using the Power Explorer tool. This will be analysis of a single scenario of the power system based on a single forecast of the different input parameters. How you can look at the sensitivity of the performance of the power system to any one single parameter. And finally, the ability to look at possible futures of the power system considering the uncertainty in all of the forecast variables. Right, so if we start on the dashboard page and you select all scenarios on the preset input parameter range, what you're seeing here are the 5 output graphs, and these show very wide ranges on each of the output parameters because this is showing the results of all the possible scenarios that you can run with the tool. So starting at the top left is the load shared energy. This is the amount of power that the system in any year could not deliver. So starting in 2023 with the 16.6 terawatt hours that was load shed, and then going forward with the full range of scenarios. The next chart, the blue, is the capacity factor on the flexible capacity. So at present, that's the open cycle gas turbines. In future, that capacity could be gas-fired, open cycle or combined cycle gas turbines. That capacity factor, one would like to see below about 10% in a healthy power system. That's the most expensive generation that's on the system. And if things are working well, you're not using that to generate that much energy. So the third chart along, the green chart, is the actual energy that is generated by that flexible capacity. Bottom left chart is the energy coming out of the coal in the scenarios, and the bottom right is the emissions from the whole power system. The colors in each of these charts show some statistical analysis of the output scenario range. So for example, the dark blue in the capacity factor chart is the middle 50% of all the output from all the scenarios for whatever input parameter range has been selected. And then the max and min of the scenarios with the widest difference in the output for that particular parameter. And the black line is the median of all the scenarios chosen, or if you choose one scenario, that is the output for that one scenario. So this is the output charts. The input parameters, we've allowed for 6 input parameters. The EAF on the coal is shown in the top left chart here. And the other parameters are all forecasts of what the installed capacity will be in the various technologies over the course of the years in the modeling period. So we've got the utility scale solar capacity, a rooftop capacity, wind, flexible generation, so this is the OCGT, CCGT, and battery. So let's start with a single scenario analysis. So if we scroll down to the input parameters, this is a single scenario that we've preset here, which would see the EAF on the coal recovering over the period, utility scale solar being implemented at a moderate build rate. We'd have 24 gigawatts online by 2030. Rooftop solar would grow to 5 gigawatts by 2030. Wind capacity as shown here, and the other parameters as shown. And the flexible generation capacity reflecting the situation where the earliest time that we'd actually have additional capacity would be in 2029. So the output charts give you the output for this one scenario. Now, of course, you can change any of the parameters by clicking on the dots. So if you want to model a situation where the recovery in the EAF of the coal is not sustained and the EAF falls again, that would look something like this. And as you can see, obviously, load shedding would, under those conditions, return to the very high levels as of 2023. Then you could look at what the impact would be of build scenarios in the other capacities in that context. So, for example, if the build rate in solar was stepped up to a higher rate, that would have this sort of impact. It's useful when comparing single scenarios to make use of the fact that this tool is in a web browser and you can make a copy of the tab and compare single scenarios with each other. So, for example, this is the default single scenario with the input parameters in it as shown, and this is the scenario as we've changed things. So you could see if the decline in the coal EF was slightly different or there was a further recovery, you can compare that by clicking between the tabs. So that's the single scenario analysis. Then if we look at the sensitivity analysis, here is where you define a single scenario in terms of all the variables, but for one of the variables you look at the entire range or some range that it could take on. That gives you an idea of the sensitivity of the performance of the system to that one. So this would be the sensitivity to a full range in all the values that the coal EAF might take in the modeling. One can reduce that range. If you look at the dots on the left here, if we, for instance, were just interested in the high EAF numbers, this is what the sensitivity of the outcomes would look like. If we change the coal EAF to a single trajectory, you can then look at the sensitivity to some of the build rates. So there's a lasso function here, which allows you to custom bounds on what the build limit might be and see what the impact that has on the different output parameters. Finally, of course, you can extend this sensitivity to all of the parameters and then contemplate possible futures of the power system, taking into account the forecast uncertainty in all of the variables. So if you look, for instance, at one of the presets we have in here on an accelerated renewables rollout, here is a situation where we are examining how the power system would perform under a certain range of coal EAF, a range of solar capacity outcomes, and a range on all the other capacities. Of course, you can customize this. For instance, if we want to see the impact of increasing the flexible generation capacity faster than is contemplated here, we can select the full entire range, and that will give us the impact on all the parameters resulting from that. Similarly, in what we've called the delayed renewables rollout scenario, you can clearly see that the risk and scope of load shedding into the future would be much exacerbated. And again, you can change any of the ranges here, customize them to understand the impact. So, for example, here you can see the capacity factor on the flexible generation is capped at 15% until 2029. This is because the build program that we are modeling here only contemplates new capacity from 2029, and the existing capacity diesel ICGTs we're modeling has not been able to run harder than 15%. But you can extend the view on the flexible generation and see what impact that has. As you can see, more flexible generation earlier has a dramatic impact on reducing load shedding. I hope you'll enjoy using the tool, and please send us your feedback and comments. Thank you.